Okay, hello everyone. So as Laura already said, I'm going to talk about serverless. First of all, let's show me some hands. So how many of you knows what serverless actually is? Yeah, me too, great. How many of you use serverless on, for instance, in production workloads? Great, perfect. How many of you wanted to use serverless but couldn't because of some kind of limitation? Of course. All right, so maybe this talk will give you some perspective, and there are some news from AWS which might give you some more tools and break those limitations. So first of all, as the name suggests, it says serverless. It is not serverless. The servers are there. There are hundreds of thousands of servers. They are just being managed by AWS. Okay, cool. That wasn't part of the presentation. Okay, there it is. So basically, the servers are underlying infrastructure as always. So even if you do some kind of cloud deployment or on-premise deployment or whatever, there is always server which is running your code. There is always a network. You might need to scale it and everything. This is being done by AWS, which is super great because they provide different runtimes. They scale it, they load balance it, and you don't really know about any of that. Usually with serverless, there is some kind of pricing model where you pay per request or you pay per usage, per duration or whatever. And usually you can scale to zero, and whenever you don't use it, you don't pay anything. And of course, there is always an option for on-demand pricing. And as I see the serverless, for me, it is, I don't want to manage my own cluster. I want someone else, especially from AWS, to do it for me, so I don't need to. All right, so serverless, AWS has more than 100 of serverless services because a lot of things, even managed services, are basically are part of this category. I'm not going to talk about everything because we don't have that much of time, but I focused on AWS Lambda, AWS ECS, DynamoDB, and DSQL today. So let's get to it. So for those of you who don't know what AWS Lambda is, is there someone who don't know what AWS Lambda is? No one, great. Just a quick recap. So it's a function as a service. It provides various runtimes. Many of them are official, some of them are unofficial. These reinvent, I believe that Rust was introduced for those who code in Rust. There are options like running Docker in Lambda. There are options like using Lambda Web Adapter, which basically allows you to run any kind of web server inside Lambda. There are some limitations like you can use 128 megabytes up to 10 gigabytes of memory, and it translates 1 to 6 virtual CPUs. The most pressing limit is 15 minutes timeout, and it also rapidly scales. It's fully managed, and it provides lots of event source mapping. For those of you who don't know what that means, it means that Lambda connects with other services seamlessly through ESM, event source mapping. So these two limits, which are in bold, those have been kind of mitigated by the latest announcements. So first announcement is Lambda managed instances. What it is, so basically Lambda so far without this option was running in a sense that you could basically allocate some kind of memory to it. The CPUs are scaling with the memory, so you cannot choose how many vCPUs you want to provide to your code. But from now on, you can, and the big disadvantage of this is that when you want to use some kind of a different architecture of CPU, or you want to use GPU even, you couldn't do that, but from now on you can. So how this works, it's again, it's Lambda which runs on EC2, which is fully managed again by AWS. You don't manage your Lambdas, you don't start them. You basically cannot do anything with the EC2 instances, but you can see them, they run in your account, so it's only dedicated to you, to your use case. And yeah, the pricing is basically you pay for EC2 instead of paying for invocations, etc. And 15% on top of it for management overhead. And I guess that 15% is really great because remember, you don't spin up the servers, you don't patch them, you don't scale them, you don't do anything. So basically, and also the saving plans and the reserved instances apply, so it might be really cheap for you to run it like that. This is great when you have like some kind of steady workload and you're already using Lambda and you don't want to re-architect or anything. So you still use Lambda model with request response, and you just can choose whatever hardware or instance type the Lambda is running on. How this works, it works like this. So basically you create a capacity provider where you specify optionally what kind of EC2 instances, what type of EC2 instances you would like to use. If you don't specify this, basically AWS will automatically monitor your workloads, and they choose the most suitable type for you. Then you associate your Lambda function with capacity provider, and then you just deploy your function. So in this picture, as you can see, this is the standard Lambda environment execution. So as you can see, one execution environment per Lambda. So basically, you invoke Lambda. There is some initiation phase. Then the invoke is running, and then when you hit the same Lambda within 5 minutes, basically it is still warm, and your invoke is without the initiation phase, which is called cold start. So basically, when you hit warm Lambda, there is no cold start. But when you scale, and for instance, you need to concurrently do 2 requests, then another Lambda is spin up, and you have another cold start. So on the right side, from your perspective, there is execution environment from perspective of Lambda managed instance. So as you can see, the Lambda, basically, when you create the capacity provider, no instances are being deployed. There is just config of how it will work. Then when you deploy your first function, you set up basically what kind of concurrency would you like to have within that function. There are some default values for different runtimes. Sorry, and basically then the EC2 instances are provisioned for you within your account. Those are read-only, so you cannot update them, you cannot do anything with them, but they are initialized, so that's the cold start, and from then on, they just run. And as you can see, the single execution environment, meaning single EC2 instance, is being invoking different requests from your Lambda. So this is kind of it mitigates the cold start, and there is a multi-concurrency there. It looks like this in CDK. This is something which I tried. I haven't deployed it. It is here just so we can see what are the options. So we can choose the architecture, the instance type, KMS filter, etc., etc. So you can scale manually by different metrics, or you can set up automatically and just forget about it. Obviously, it needs to run within VPC. Okay, and this is how you set it up with your Lambda function. So basically, it's just uh, standard Lambda function which you deploy really standardly, and then you added that Lambda function to the capacity provider. You can set up the memory to CPU ratio and max concurrency for the single Lambda, basically. All right. Okay, this was the first limitation of not being able to choose the architecture, the CPU, the GPU, etc. The second limitation was the 15 minutes timeout. And so that's why they introduced the durable functions. And the durable functions, I don't know if any of you know step functions. How many of you know step functions? Great. So step functions is orchestration tool for Lambda. So you can put multiple Lambda functions in the workflow, like flow chart, and do a lot of steps and conditions, waits, etc., etc. And the Lambda durable function is very similar, except it runs within the single Lambda function. So AWS provides powerful SDK. So far, they provide SDK for Node.js and Python. There are more coming, obviously. And it looks like basically within your code, instead of going somewhere else and do all of the step functions, JSON configuration and everything, and orchestration, you just use your favorite language like Node or Python, and you code your steps within the same file, even if you wish. And then you deploy it with the special configuration of your Lambda, and then the durable function basically manage your state. You have similar things like step function. Basically, you can do the checkpointing and retrials and everything, waits, and everything is automated through the SDK. This obviously addresses timeout and orchestration limitation. You can run the function up to a year. So basically, this is execution timeout and retention period. So it's really similar to step function, but instead of orchestrating multiple lambdas, it runs within single lambda, and again, it's fully automated, fully managed. I've done a little super simple demo because I just wanted to know how it works, and I didn't want to talk about it without even trying it. There is a QR code where you can see the gist with the code. I'm not going to show you the code, so if you want, you can scan it. I basically had just 3 problems with it. First of all, there was a problem with permissions, as always. So that was obviously something which I needed to kind of overcome. Then when I deployed to the Node.js 24 runtime, the problem was that the provided SDK within the runtime was older and didn't have all of the capabilities. So I needed to bundle my newer SDK with it, and then again permissions. So yeah, it's always permissions. This is how it looks like in your console then. So basically, you can see all of the steps, and you can see the demo contains basically just waiting for a callback. So what you can do is you have your code. I'm not sure if I have it there. No, sorry, I don't have it there. So when you see the code, basically it's just waiting for callback. So you can code your workflow, and then you call the provided SDK. And it will generate callback ID. You call some service where you send that callback ID, and then your function freezes and it stops. It persists the state, and then whenever the third party or whoever do their work and they call the durable function with that callback ID with the response, again, the function, the original function code, it just is spin up and then it continues with your workflow, which is really cool. Okay then, so I talked or I mentioned step functions and durable functions. What and when and how to choose between those, it is really, it depends as always. So when you have already something within the step functions, I wouldn't go and convert it to durable functions. If you always wanted to try something like step functions, I would go for durable functions, definitely, even especially if you have workloads in Node.js and Python. If not, then obviously there are no SDKs yet, but there will be. Since I watched a lot of things on AWS reInvent, I suggest you to see these two talks. First of all, the first one is about the durable functions deep dive and introduction. The second one is from the same guy, Eric Johnson, about step functions, and he also compared them and tells you which one is better for which use case. We got it. Okay. Okay. So there are just few things which is worth mentioning about Lambda. These four. So Lambda roadmap is public on GitHub. So if you want to know what's next and what's coming, what's in the research, you should just basically search for it. It's really easy to find out. Then there is something which is called tenant isolation. It's pre-invent. Basically, it's publicly available from pre-invent, and it is about isolating your Lambda execution. So if you have some kind of SaaS or something like that, some SaaS solution, and you would like to isolate different users, you can do this. So previously, you would need to, as a first step within your execution of the Lambda, you would need to make sure that temp file is empty or there is no other something within the within the memory, etc. With tenant isolation, you just set up customer ID or some kind of token for the particular customer, and Lambda makes sure that for this particular customer there will be always the Lambda spun up just for him, and for another customer there will be another Lambda, not the same one reused. Also, there is a support for egress-only internet gateway, which for me it's really good news. It supports only IPv6 and it works with Lambda. So basically, when you have your Lambdas in private subnets, you don't need to use network gateway anymore. You can use egress-only internet gateway, which is for free, so you don't need to pay for anything. The only catch is that it supports only IPv6. So most of the services from AWS are okay, that they're running on IPv6, but if you are using some third-party APIs or whatever, you need to make sure that they support IPv6 as well. And for the step functions, there is a new thing which is called JSONATA, and this is basically transformation tool for JSON. So you can really quickly transform your JSON file or whatever. And the step function has support for it. So when you have like step function and you have Lambda, which only transforms some data to put it to some storage, to DynamoDB or whatever, you don't need to do that. You can use JSONATA and basically not run that Lambda, meaning that it's more cost efficient. Okay, ECS. So another compute, serverless compute, which I'm going to talk about is ECS. How many of you know about ECS? Great. So it's basically for all of other you. Basically, it's it's native container orchestration service. So it's similar to Docker Compose or Kubernetes or any other orchestration service. It runs natively in ECS. You can choose 2 options, Fargate and EC2. Fargate is serverless. There is no control plane to manage, so it's fully managed. There are blue-green deployments. You just specify tasks and services. Basically, this was a workaround before durable functions that when you have something which you needed to run for more than 15 minutes, you usually would use Fargate task for that. And of course, you can deploy this with CDK, CloudFormation, AWS Copilot, etc., and any other third-party infrastructure as a code. And as with Lambda, also ECS introduced managed instances. So basically, previously, without managed instances, you have 2 options: Fargate, where you can choose how much memory you want to use within your task or service, and how much vCPUs you want to use. And then you would just run it, and you didn't have option of telling the AWS to run it on this instance type or with these capabilities of processor or whatever. Now with EC2 managed instances, you can do that. Previously, you could do that with EC2 provider, but in that case, you would need to manage those EC2 instances. So EC2 instances were deployed for you, but the AWS didn't manage them. So now you can have a third option. So you just need to create new. There is a new capacity provider where you select managed instances, and you can select EC2 type and capabilities and everything. And it is, again, fully managed for you. You can see the instances, but again, it's read-only. You cannot do anything with those. They're scaled automatically. There is approximately 2-week retention for instance, to get patched, etc., etc. And yeah, and that's it about that. So next serverless option is DynamoDB. How many of you know DynamoDB? Great, perfect. So just quickly, it's schemaless NoSQL key value storage. It's highly available, scalable, and fully managed. And it has 2 modes of consistency: eventually consistent and strongly consistent. It also gives you option of strong consistency in multi-region, which is super great. And there is the QR code for talk from Alex Debris, which wasn't part of reInvent. It was prior that at the DynamoDB day, and he said that with DynamoDB you are the query planner. So this is the most important part for me, or for you to realize that there is no query planner with DynamoDB, so you need to optimize your queries. And this is why I'm talking about it, because there is a new thing which was introduced, multi-attribute composite keys. So you have your data usually in DynamoDB. You store it with primary key and sort key, or without sort key, whatever. And when you want to efficiently get some data with other view or other access pattern, you usually create a global secondary index. And that can have, again, partition key and sort key. And now you can have more of the attributes can be part of the global secondary index. This means that for hierarchy access, like filtering based on country, state, province, city, you don't need to create any more these kind of synthetic keys, but you can use you can create GSI with those attributes instead. So you don't need to copy the data to the secondary index, but this will work. Okay, there is no support for primary table key though yet. They told that they might consider to add in it. And another serverless option for database is our DSQL. Anybody hear about that one? Okay, so basically DynamoDB is highly scalable, but you don't have standard SQL. You have DynamoDB model. You need to make sure that you model your data in a way that you can then fetch them efficiently. But with our DSQL, this is distributed SQL database. It's Postgres compatible, and it's pretty much as scalable as DynamoDB, and it's fully managed, and you can use it with your existing application. You can switch with ease. There are some constraints, obviously, because of the distributed nature of it. So there are no foreign key constraint support, for instance. Everything needs to run within the transaction and stuff like that. There is something which is called optimistic concurrency control, which they are using this model, and there is also a tale of two transaction talk, which if you are interested in that, I recommend to see that talk as well. And of course, as always with deep dive and on architecture, I recommend you to see other talks from AWS re:Invent as well, just to see, maybe not really great for usage or whatever, but as an engineering kind of to see how things are built and how they are engineered. Okay, and lastly, there are some things for local development. So basically, this is just the honorable mentions. You can use in your VS Code AWS Toolkit, which now has support for local stack. So you don't need to deploy everything to AWS, but you can deploy it to local stack. Local stack is just Dockerized AWS simulator, basically. And it's much quicker than deploying it to the cloud. I really like the idea of testing the CloudFront functions and CloudFront Lambda at Edge with the local stack, because you don't need to wait 15 minutes for distribution. Then you find out that you make an error, and then again. So this might be really helpful. Then again, they introduced, well, it's not introduced, but there were some talks about remote debugging from VS Code, which is really interesting because you just simply click a button in your VS Code, and suddenly it is deployed to the AWS. It runs there, and you can see exactly the stack trace and the values and everything in your local machine. So really great for debugging. And that's it. So in here, there are, again, 2 QR codes. First of all, a big thanks to Martin Damovsky. And he created a tool, unofficial tool for Rewatch. And the second one is my playlist of selection of the talks I've seen or I think are really interesting. So if you are interested, you can scan that and see that. And that's all from me. Thank you very much. So are there any questions? Yeah, go on.
Yeah, may I have a question?
Yeah, go on.
Lambda Edge instance, you mentioned it earlier. Well, so let's say I have like 100 lambdas, which let's say half of them needs to run like all the time and half of them not really. So basically, do I need for these 50 lambdas, let's say one single instance, or I need to have each instance for each lambda? Can we schedule like to a single EC2 lambda instance, right? Up to max capacity of the instance?
Yes. So what you do is you don't actually choose how many lambdas are being deployed, because you just configure your capacity provider, and those lambdas are being spin up or down by AWS. So based on the traffic, based on the load, there is max concurrency limit option there, which there are some sensible defaults, like 64 for Node.js or something like that. If you need more, you can change it, but maybe it won't work for you, but you can tune it up or down. But you don't really manage those instances, so it's being automatically scaled for you.
So I don't need to be worried about the max capacity?
No. So basically, if half of time you run 100 of Lambdas and half of time just 50, it will just provide you with 2 instances for half of time and 1, yeah. So it scales seamlessly for you.
And it scales up to 0?
I believe. Well, I'm not really sure. I'm not really sure.
It doesn't scale to 0?
It doesn't scale to 0. So yeah, that's the thing that since it doesn't really scale to 0, it's not really that great for like spikes or whatever. So if you have like a steady load and you know that you will use it, then it is great. But other than that, yeah, if you have like not really predictable load, I would still stick with the standard Lambda. And there are also some partners, I don't remember the names, but there are some partners which were mentioned in one of those talks, which monitor your workload before you switch to LMI. So basically, they monitor your workload and they recommend if LMI is suitable for you or not. So you can even use those. I don't know the names, unfortunately. Hey, sorry, go on.
You mentioned when interfaces there are strong, consistent services like DynamoDB, something. So I guess for DynamoDB and S3 this is a lead after write consistency, but for this distributed PostgreSQL that is really ACID transactions.
Yes, they at least they claim so, and there is like the whole thing, the whole consistency of the SQL. I've watched the talk, but I'm not really. I don't really can tell you the exact fact, but the one of the thing which they use is TimeSync, the service which they created like from the ground. They use GPS satellites and really atomic clocks and everything within their data centers, etc. So they are able to really do this in scale, like multi-region, because they have exact timestamp in, I believe, microseconds or even nanoseconds. So that's why they can do this. And as I mentioned, it was optimistic concurrency. So they kind of do it optimistically, and then if they find out it doesn't work, they just roll back.
When I'm using LMIs, can I use my custom AMIs, or is there no option to use custom OS images?
Well, it's just a runtime, but you can. It is like standard Lambda. With standard Lambda, you can use AMI, and you can use Docker or whatever. So this is exactly the same. The only difference is that with standard Lambda, everything runs on EC2, obviously, right? But in standard Lambda, those EC2 are shared between all the customers. It is like service. And with LMI, you have your own cluster of EC2 instances. But the underlying infrastructure, OS, and everything that's being managed by AWS still. But you still can, if you have some special kind of need for whatever, you still can use Docker with Lambda and add to Docker whatever you need.
Like what I was asking, we are using hardened Amazon Linux some images for the baseline OS on our EC2s. I guess this is not an option.
No, definitely not.
Nice. Okay.
No.
Thanks.
Maybe I would like to ask more about details about the durable functions. When you were talking about this comparing to the step functions, so maybe I didn't get it, but the let's say war logic is direct in the code. Workflow is direct in the code, and I'm just calling one lambda in this workflow.
Yes. So sorry, it's my mistake. I thought that I have a code snippet there, but unfortunately it was too long to fit it in the screen. But yeah, basically what you do is you call SDK, which they provide. you wrap your Lambda handler into it, and they provide you with the context and the durable function context. And on top of that context, you can call various functions like step, wait for callback, wait with timeout, or decide, or whatever. All of these things which you could have done with step functions, you have in your code within the SDK. And basically how it works is that Lambda starts, it executes by these steps or whatever, right? And whenever there is a wait, for instance, the whole context is being persisted. In the background, they use DynamoDB, and everything is automated. And then even if you wait, for instance, for callback or whatever, you can set up various things like timeout or heartbeats, even to see if the downstream is even live at that time. And if it timeouts, you get error. If it doesn't, if you get a response, the whole Lambda is being kind of spin up again with your code, and you are checkpoint to the particular step which you haven't done yet, right? So you get the response, and the code basically just continues. And it's all really, it's really nice because it looks like synchronous code for you, like JavaScript. You can use async await, whatever. And but in the background, it is really like complex architecture, similar to step function.
But maybe one disadvantage compared to step function, I don't know what's this visualization anymore, right? In durable function. So I can see workflow how it's being.
I don't think that there is a visualization, sorry, but I believe that if that's something which is missing, they just add it there, because it shouldn't be that complex to add it there, right? But yeah.
Thank you very much. And one more question regarding the Lambda managed instances. Do I have an option to connect these instances to private network, or it is completely transparent for me and it's connected somewhere in the AWS network?
Lambda managed, no, it runs within your VPC. Okay. So as a part of as a part of capacity provider, you specify your VPC and your subnets. So you can use any type of subnets, public, private, isolated, whatever. And basically, it is exactly the same model as with standard Lambda, but it runs in your account, and you even choose which type of instances you want to run.
Okay, perfect. Thank you very much.
Sure. And you wanted to ask?
Yeah, I have a question about the durable functions. When you said that when you're waiting for something, the state is being persisted, do you have to like explicitly state what you want to persist and then you can use it, or is like the whole memory being stored some like VMs or?
I believe that well, the state of the durable context is being persisted. I don't know. I don't believe that the global state is being persisted. I didn't try though. But if it is, then it is. If not, then probably they have it in some kind of best practice to not to use it and to use some alternative. But basically, the state of the state machine is being persisted, right?
Okay. So, for example, something loaded in some global variable.
I don't know. I don't know, to be honest, but maybe not, maybe yes, maybe not, I don't know, sorry, cannot answer that. Anyone else? So I guess that was it. Okay, thank you very much.